Welcome to the podcast dedicated to the art and science of observability. This is Signal Over Noise. Hi, everyone, and welcome back to another episode of Signal Over Noise. Today's topic, the roadmap to self-driving data center networks. Joining me today to shed some light on the topic and the best approach when it comes to observability and AI workloads are our very own Alex Degitz, VP of Product here at ElastiFlow, and Kyle Baxter, Director of Product Management over at HPE. Welcome to the pod, team.
Thanks. Good to be here.
Thank you.
Awesome. So before we dig into it, Kyle, would love to hear, what have you been up to lately over at HPE?
It's been a busy year. As many people know, HPE acquired Juniper Networks. So I was on the now ex-Juniper team, but it's been a busy and exciting year as we've been integrating Juniper networking into HPE's overall solution and offering. And so it's been really exciting to see that vision of being able to offer a full stack solution, which now includes HPE servers and storage with Juniper's networking portfolio, and how we can provide a full comprehensive solution, and how we can ultimately get to our vision of self-driving networks. Because the whole idea of networking is to serve applications, and we want the networking to work seamlessly and not be the problem. And it's always best when the networking just works and people aren't talking about it. So it's been a really exciting year and a lot of great innovations and integrations that we've been working on.
You mentioned self-driving networks, right? That many people might think of something slightly different when they hear that phrase. Like, how do you define it?
Yeah, so we equate it a lot like self-driving cars, where there's multiple stages. You don't just go out and just expect it to work and expect a car to just drive itself. It's about starting with the right data, and even more importantly in today's world, with the right APIs. Because everything is about integrations, and with MCPs becoming popular, you need good APIs and you need amazing data to really make that happen. So that's where it all starts, is the right insights with the right data. And then you build upon that and you get to guardrails, just like you have in a self-driving car. You start with the sensors that can then detect things that, hey, you're about ready to run into something. And then you get to the next stages where you get recommendations on, hey, how do you turn? Which direction do you go? And then eventually into some level of assistance and then full self-driving. And so that's where we're doing a lot of really exciting work, is how do we get to that vision, and we go through those different stages and give the users, in this case, the network operators, the confidence that the network is doing what they expect, and they can trust the tools and the process to deliver what they expect and what they intend and need.
That makes a lot of sense. Yeah, I like the analogy with self-driving cars, because people can very much relate to that. They see them out there. Yeah, see all the Waymo cabs now that just became legal here as well.
Yeah, they're everywhere these days.
Yeah. What stage? You mentioned like a couple of stages, like data collection, processing, suggestions. Which stage would you say we're at right now with your product?
Yeah, we usually break it down to about 4 or 5 stages. So similar to how I kind of talked about, starting with the quality data and insights, getting into recommendations, and then getting into a level of assistance. And that's where we're at, where we can be able to leverage the right data we have, the right context of information, which is absolutely key. Just having more data isn't helpful, but having the context and the knowledge about what that data means and what it correlates to and how it's used and what's relevant. Common example we use that a lot of people can relate to is we don't just get data and tell you, hey, you have 10 BGP sessions that are up, but actually you should have had 11. And so you're missing one, and one of them is actually configured that's up. And so you're going to have problems. So having that context on that data truly matters, not just, hey, you collected the data, but what does it actually mean? And so with that and our combination of what we can do with our AI technology is be able to leverage and be able to provide insights and recommendations, help you troubleshoot problems, get to the root cause, and know what actually you need to go do to go fix it. So very much like a seasoned network assistant right there in the product to help you be more efficient and operate faster and get to the outcome and the solution you need and intend to work.
Yeah, that makes absolute sense. And it's such an important area where there is a major shift now that we have, that we talk more about agents, that we talk more about LLMs actually helping out with that, right? Because I feel like traditionally, very much what was the case was we collect all the data that we can, right? But the usefulness of the data was basically limited to what we can actually either efficiently search by, or in recent years, more like what I can show in a dashboard. Right? If the data point is not in a dashboard somewhere, it's almost like it doesn't exist, maybe outside of like log debugging, stuff like that, right? But if you're looking at metrics, if you're looking at what's running in your network, we see that all the time from our side, right? Where people want additional enrichment, people want additional business context. They say yes to all of that when we talk to them, but oftentimes the missing part is actually, if it doesn't show up in the dashboard, it's almost like it doesn't exist. Right? But yeah, on top of that, going forward with the AI ability to help troubleshoot, to correlate, to do all of that kind of stuff, right? I think it's easy to run into the fallacy of more data is better, right? Because now I have my AI that can just run through that, right? But that I believe that's actually not the case for a couple of different reasons. But I want to get your thoughts on how you think about data collection, extended data collection, as like usage of that raw data shifts more and more from like humans looking through it to like AI guided systems looking through it.
Yeah, totally agree. Almost it comes to a play where we use AI a lot to decide what additional data it needs to go get. So based on the data and the context we have, it may say, hey, I'm missing this or I need that, and actually go out and pull it from the devices we're monitoring and managing, and then get that complete picture. So that's where AI can help us, that way we're not just getting and storing lots and lots of raw data, not doing anything with it, but getting the right key data where then we can leverage the insights to say what additional data or insights do we need to go obtain, whether it's run some additional commands or pull some additional data off of wherever that is stored to be able to complete the full picture and give that end-to-end view and insights.
Yeah, and that's exactly right. I love that you mentioned that the pulling, right? It's not, I think it's not feasible to collect one single source of truth into your super large database about everything that's going on, right? That's not possible, I believe, in most cases, but also not beneficial because it would just be too much. So there's like point in time outreach, like something that we're looking at in our product right now is the simplest thing. Like we talked about a lot about, we have to have an MCP server now, right? Because everyone has an MCP server and it needs to do cool things. And so we're just thinking about like, what would be an actually useful tool for our customers to have in an MCP server that is like deployed on an agent close to the network devices, and actually like allowing it to ping, right? Basically saying like, hey, an agent that looks at data in our observability platform, they can just always reach out to our ElastiFlow collector and just ask, hey, is that device pingable right now? Without a user having to do that themselves. And especially if we, for example, don't get SNMP data at the SNMP polls, but we don't know exactly why we're not getting those, right? It's just, it's not this super sophisticated stuff. It's actually like, it's helping us with the basics and makes us quicker. And if your AI agent can say like, oh, I've already pinged the device, I know it actually is live and responding, we're just not getting polls. So that's one thing less that the network engineer can do. And then they can focus on some higher value tasks.
Yeah, totally agree.
So as we think about this roadmap to self-driving networks, where are we today? How do we know that we are ready to take that next step in this roadmap? Kyle, maybe you can expand on some of those requirements.
Yeah. So a lot of what we're focusing on is giving our users the right data to understand the different stages and what we're recommending, or even what we're predicting is going to happen based on different AI and ML models, where we can look at trends of what has happened in the past to look at what is going to happen in the future. And so where a lot of conversations with network operators that I have is trust in those systems and those predictions and recommendations, and how do they trust that? So building that trust is key. And so a lot of where we're focusing on is how do we give the data to back up what we're recommending, what we're predicting, what AI is saying and thinking, and the confidence level. And so a lot of ways we do that is we give visuals on, well, what is the confidence of that prediction, and then dive into what is the data that backs up that prediction, and summaries and recommendations of what it is. So that way users can begin to trust it, understand it and be able to then leverage it long term and know that it's going to work as they expect and as they want. And then as we get to true self-driving, where we're actually automating actions, a lot of what we want to position is opt-in models, where the user, after they built that trust that I talked about, can then say, yeah, I opt in. I know you know how to fix that and address that. I'll opt into that automated action model and be able to leverage that for my optimizations going forward. So that's a lot of what we're looking at is the key is on trust in building that relationship to know that it's going to work. Without that, it's back to that analogy of a self-driving car. If you don't believe that that Waymo or whatever your automated car is doing is going to actually get you to your destination, you're not going to get in it. You're not going to trust it. You're going to have issues believing it. So that's where a lot of effort we're spending on. It all starts with the right data in the right context. So that's absolutely key on how we do it, is getting the right data to start with.
Yeah, that's a great point. The same problem, that we've, I think, always had, right? It all starts with the right data. And I'm going back to my security days. It's you can't secure what you can't see. And so let alone automate it, right? It's going back to that foundation of the right data, the right context, and making it usable.
And what you're mentioning there makes me think a lot about future tuning of alerts, right? Because the worst possible outcome of a system like the one you're describing is basically, oh, now I have more alerts for my network engineers to go through, right? Even though they might have all the data and all the truth and all the evidence that something will actually break, right? And you'll need to fix it. The worst thing that could happen is to have just more alerts on that. But I think it's a big chance for us to remove the number of false positives we're getting on the alerting side, right? That we can actually scale back a lot, maybe the manual alerts we're setting, right? Because as we trust more that we're actually getting those insights correctly from like the self-driving network and those suggestions, I think the less pressure there is to fully look at the SNMP traps and have all the 1,000 alert rules around it and make sure we're refreshing our dashboard every 2 seconds to make sure we're never missing that an interface goes down or something like that, right? We probably, like, that's kind of what I'm seeing in this area, is like we can ease off of that a little bit because we have more of those proactive tasks available.
Yeah, I totally agree. That is definitely also top of mind with me and the team as well, on how do we not create anomaly and alert fatigue and just overwhelm with more on. And that's another way that we can use AI capabilities, is to help us troubleshoot and root cause and reduce those alerts and be able to correlate based on the right data we have to get to what is the actual actionable key events that the network operator can take in actual next steps on, and not just, hey, I got these hundreds of anomalies and alerts. What do I actually do? We can help summarize that and say, hey, here's the one event you actually need to go focus on, or a priority list of, hey, do this, this, and this, and then you'll get to the right outcomes that you want to achieve.
Yeah, that makes perfect sense. How much of that what you're doing with self-driving networks, how much would you say is specific to network, right? These very network specific data, network specific tasks, automations and stuff like that, versus how much of that is just like general observability, right? Because I feel like we're all very different companies try to tackle the same problem from a lot of different directions. Like with OTel becoming more of a thing right now, we have like more standardized data schemas, and something that we've talking about here at ElastiFlow all the time is like, how much are we all going to come up with a very similar solution from the network performance monitoring, application performance monitoring, those kind of things. So what's your take on that?
Yeah, I think there is a lot of overlap in how we go about solving the problems. Even within HPE, we're re-leveraging and reusing a lot of the same AI and ML techniques across our entire portfolio. We were already starting to do that as part of Juniper, where we're using common AI across our entire networking stack, from wireless campus network to your campus WAN to your data center. While they're all different use cases of how networking is leveraged and utilized, it's still at the end of the day, it's moving packets. Yes, wireless is going to have radio frequencies that come into play, and WAN will have its unique challenges, and data center has its own unique challenges as well. But a lot of things we can leverage common frameworks. And even when we take it outside of the pure networking stack, we're looking at a lot of that at HPE because we also sell servers and storage and security solutions with firewalls and many other offerings that we have. And we're reusing a lot of the same core functionality and tool sets across a lot of the capabilities. So I do agree, Alex, we'll see a lot of convergence on how we go about solving the problems. What will be unique and what will differentiate is the outcome driven for that specific use case to solve a specific user's problem. Like when we see on networking, they have very specific problems. How they go about and how the tools we use to solve it may be very common. But we'll see more success when we get to the outcome driven use cases. That's will be how and who will differentiate in the market going forward, is those that can drive unique outcomes and solve real problems.
For sure. Yeah, well said.
So when we focus on, you mentioned, different environments, different challenges. When we look at data centers specifically, what are some other milestones that we need to achieve before we can truly look to a self-driving network?
So I think there is definitely some things we can look at in addition to what I've already mentioned, from having the right data, also the right APIs, and then providing the trust that we talked about. That's a lot of our three key pillars, but there's other things that will go into it around using the right frameworks. And where I see a lot of this evolving is it's not a one and done, you've delivered self-driving and you're done. It's not, hey, we can now claim victory. A lot of this is going to be a constantly evolving capability. And we're seeing that as we're building it and developing it, that we'll get one model up and we're happy with it. And then we notice, oh, we can make all these improvements here or there. And so I think a lot of what we'll see is continuous improvements and new updates and evolutions, similar to how we're seeing that in all the LLMs out there, that the latest model then jumps whoever the past one was, then everybody moves to that LLM, and then the next one comes out with a new version, then we all move to that one. I think we'll see a lot of those evolutions as we continue our journey on leveraging AI for self-driving networks, is that continuous evolution of models and how they improve, the accuracy they get, the new capabilities and use cases that they can leverage, additional data that they can be able to use as well.
I think that's a very great point. And I'm hoping that our listeners are, there's a sigh of relief here, right? Because a trending topic, AI is going to replace all of our jobs. So how can we kind of calm those nerves, since we're on this roadmap to self-driving networks? AI is not taking our jobs. We are still playing a very critical role within this, right? So how do you see, I guess, a role of NetOps, of DevOps evolving as we get closer to that finish line of that self-driving network? Or maybe there isn't a finish line, right? Because like you said, constantly evolving, constantly a change. Going back to that question, how do our roles evolve within this?
Yeah, I think the role of network operators is definitely going to evolve and change. I don't think there's any risk of it getting replaced unless you don't use some set of AI. For those that aren't going to use AI, they're going to get left behind. But those that are, whether it's the ones we're talking about today or whatever tool you're using, where we see and where we help kind of relieve concerns from network operators as well, is we're not there to replace your job. That's not what self-driving networks is there for. It's to enable the network operators to do more with the current time and resources they have. So how do they help their own business grow and deliver services faster? We've all been there, that when ready to deploy something and the network's the last step, how do we make it so that the network's always ready and always ready to grow and expand and be there and not be the bottleneck, not be the problem that, oh, we got to wait for the network to be ready? Or with the networks, obviously the problem here, we shift the story away from the network to how do we focus on the services and applications that network is offering, to focus on those, and how do we grow that side of whatever business it is that is using the network. And so that's where
That makes
we
sense,
truly
yeah.
see the value of self-driving networks is not replacing network operator jobs, but turning them into we call them like dev net ops. So they're leveraging the tools to work faster, to implement quicker, to get to the root cause faster, and deploy a better network.
Yeah. Yeah, I fully agree there. I mean, we talk a lot at ElastiFlow about like the network operators being the unsung heroes of that make the modern life happen, really, right? Because I mean,
Yes.
and it's unsung here, in a way, it's such a hard job, right? Because I mean, no one ever said like at the end of the day, man, nothing went wrong in my network today. Like all my websites loaded fast, my Zoom meeting went great. Like no one says that. It's only ever talked about in a negative connotation of like, oh man, this is slow, this does not work, or whatever. Like that team takes
Right.
way too long to open the port for my new application, whatever it is, right? So whatever tools we can give to network operators to make their life easier, to make sure we just enable them to be better, to build more, right? Because I mean, they are engineers, right? They like building stuff, they like architecting stuff. If you can enable more of that and less of like, okay, let me run over to this device and log in there and figure out what's going on, right? There's that's really highly appreciated, I would say. I think the anecdote I always go back to is in previous job, we were automating methods of procedures for large service providers, and basically what they did is, I mean, if you have like a backbone router upgrade, right, that happens in the maintenance window between like 2 and 5 a.m. in the morning, right? And so obviously a bunch of crews are involved there, right? And I mean, they used to be able to do like 2 or 3 in the manual process, and after we've automated that, they did like hundreds of them in one maintenance window, basically making sure they have to do that once a week, right? That 2 to 5 a.m. shift, and not every single night, stuff like that. Those like ways of you can improve the comfort, improve the life in general of network operators. I think that's what we'll see a lot, specifically also because network always seems to lag behind a little bit, right? I feel like in a lot of ways, it's like, oh yeah, the cloud engineers, the DevOps engineers, they get to play with all the cool stuff, with the containers, with those kind of things, right? And the network engineers, they still SSHing onto a box kind of thing, right? I feel like AI levels the playing field almost, right? Because now like everyone has access to very commoditized automation tools, right? And they can also now build scripts easier, run them easier. So that's what I'm very excited about.
And that's a fantastic setup for my next question. So recent research from EMA states that 74% of organizations are actually looking to change their network observability tools. So as we talk about the importance of having the right data, the right context. And Alex, like you said, those shiny new toys that NetOps now gets a piece of. What are some non-negotiables, some requirements that folks should keep in mind as they look to explore new solutions for their observability?
Yeah, why don't you start, Alex?
Sure. Yeah, thanks. There's a couple of trends that we're looking at, right? I mean, obviously on the DevOps side, OTel has become the de facto standard, OpenTelemetry. We talked about it a little bit before. It's not really existent right now in the network space. I mean, Cisco's acquisition of Splunk, and Splunk being a major contributor to OTel, right? We're bringing that in somewhat. For those of you who have following Cisco's latest blog posts and Cisco Live events and stuff like that, OTel is being pushed more and more. Even like the Cisco Thousand Eyes and similar products, they now have links into Splunk, sending data to Splunk within OTel formats. I see that happening on the network side very quickly as well. That will just, instead of setting our flows, instead of sending SNMP traps, syslog, instead of sending those kind of things in like that native text or JSON format, whatever, it will be sent through OTel and to OTel collectors, just again to finally be vendor agnostic on the network side as well, right? That you don't have to, changing your network observability tool is not a 2-year project that you might tackle, which currently more often than not is the case. So that standardization I'm really, really excited about. So that's, I would say, the first thing is like, if you choose a new tool right now, like choose one that's OTel native, that has OTel outputs, so that you just like not locked into yet another vendor that you have to switch away from 2 to 3 years from now. Probably the biggest one, I would say. The other one that, I mean, is actually kind of related to the OTel movement. When you have common schemas across teams, right? The data that the security team collects, the data that your DevOps team collects on the APM side, you're actually democratizing access to that data as well. And so it makes it easier to share, easier to export, easier to all look at the same dashboard, look at the same screen to troubleshoot together rather than the finger pointing that we often see right now, because each team doesn't understand like each other's tool or doesn't have access to each other's tool, right? So it's just like, oh, our tool says it's the network's fault, so let's open a ticket there and forget about it and blame them, kind of thing, and vice versa. So I think both of those things will happen in tandem, that teams probably will move closer together. If you look at DevOps, right, it's not just software engineers. The software engineer, the design person, the QA person, right, that are in one team together, the ops person, that are all just working together to make something happen rather than having those silos. I really hope to see that as well on the NetOps and DevOps side. I think having a common data schema is the way to get there.
That's a great point, Alex. I'd kind of build on that and say another thing that is key for people to look at is good APIs. So in addition to like OTel streaming for what you were talking about to stream data, but good APIs, because one of the advantages AI has provided us is with a few good prompts, we're all now capable developers. We can all build something very quickly, and that turns everybody into the potential of being a dev network operator, and using APIs to build workflows and integrations, whether you're pulling that into Ansible or Terraform scripting or into higher level workflows and integrations, that having good, capable, and usable APIs that extends and uses everything that the product can provide is absolutely key, because everybody's looking at how do we automate more and how do we bring in those workflows and experiences.
I could not agree more. Like API first is the key to any automation, right? And I mean, people again talk a lot about, oh yeah, no, I'll just have my MCP server handle that. But I mean, like in 90% of the cases, they're just calling an API in the background, right? So they're only as powerful as the APIs that they have.
Totally agree.
All right. Now it's time to get a little controversial. It's time for some hot takes. So in this segment, I'd like to share your hot take. So something that you think might be a little controversial, your hill that you're willing to die on, something to share with our audience. So Alex, let's start with you.
Sure. I'll go with one. Everyone at ElastiFlow has heard me talk about that a lot already, but I believe the mean time to resolution, MTTR, is one of the dumbest metrics anyone could have ever tracked. And it's so ubiquitous. Like if you go to any observability platform's website, right? I mean, the words or the phrase MTTR, reducing MTTR, is like within the first 10 words that you read on that website, right? It's so ubiquitous, so everywhere you look.
Marketers are shaking in their boots right now.
Exactly, and it's one of those things that almost became meaningless because just everyone's talking about it, right? I mean, and no one really also gives you a percentage of by how much they're reducing it, right? It's just like, oh yeah, sure, we reduce your MTTR. Obviously, that's something our platform or our product, our tool can do. But then you really think about it, right? I often want to say, like on our website, right? It's like, oh, like ElastiFlow helps you increase your MTTR, and then people are like, what are you talking about? But if I'm thinking about like MTTR, like if there's outages that you can figure out how to solve within the first 1 or 2 or 3 minutes, right? Like you should have been proactive around them. Like if you had the right data, if you had the right self-driving network, Kyle, that you were talking about, like that's something, if it's that easy to resolve, you probably should have taken care of it before it was actually an outage, right? And so that's what I'm saying is, like with ElastiFlow, for example, we give you the right data so that you can be proactive about those outages that should have never happened in the first place, so that you can actually like hopefully have only the ones that are like really hard to solve, or that really like where something very complex, very terrible runs wrong, those kind of things, right? Which I mean, likely will increase your MTTR, right? But it will decrease the number of outages and the number of minutes and hours your service was actually down. So while it might increase your MTTR, it will definitely also increase your overall service availability.
Interesting. Fewer incidents, but I don't necessarily want to say more interesting incidents, but you know, the bigger challenges that we should have been focusing on instead of the, and we talked about this earlier, what we think is interesting is very different than
like a hard tone.
Yeah, what's your hot take?
So I truly believe that we are on the verge of getting to self-driving networks. People have been talking about it for for probably years now on like, hey, self-driving is right around the corner. And that was probably 10 years ago. And that automation is going to solve all our problems. But I truly believe with the advancements that have come in the AI space and how we can use that and what we can do as an industry, we're right there on the verge of actually seeing self-driving networks similar to what we've seen and how cars have taken that turn recently. That I think we are right there, that in the next year or two, we will actually see self-driving data centers running out there in the wild and leveraging AI capabilities to be able to root cause the problem or predict the problem before it happens and go out there and fix it before an outage causes. So then to Alex's problem, we get to even bigger and longer issues that get harder to solve. Automation and AI will be solving all those routine day-to-day problems and issues that pop up and be able to provide a even more reliable service.
I love that, and solving it through amazing partnerships like HPE and ElastiFlow. So that'll be my last marketing note of this one. But thank you both so much for taking the time to hop on and guide us through this roadmap to self-driving networks. Kyle, we'll be sure to link your latest paper in the show notes, so everyone be sure to check those out, whether you're watching us on YouTube or listening to us on Spotify or Apple Podcasts. But yes, thank you both so much for taking the time to join us today.
Thanks, Sara.
Thank you, Sara, for hosting us.
Yeah, thanks, Kyle. I think you're our first external contributor here for our Signal Over Noise podcast. Special shout out to that, and we'll have you back a year from now, right? To see if your hot take came true and where we're at it.
Yes, we'll see if we have self-driving networks and longer MTTRs.
Yeah, exactly. We'll have you give a demo on the self-driving network. Yeah.
What I'm hearing is that the next conference you're going to be in the Waymo giving the demos for the
exactly.
for joining us, and thanks everyone for listening. Have a great day. We'll see you next time.
Thank you.